So, all right, so we're trying to do x minus 1 times x plus 5. There we go. Greater than 0. Polynomial and rational inequalities. So we want to do that. No, we do not have to grab. I'm trying to think about what would be the best way. Yeah. First off, you know what's hard? You know what's tricky? Well, there's a lot of things tricky, but one of the hard things is recognition. How are you going to recognize this? There's something different about this problem that we haven't had for months. Good, it's not an equals. It's the greater than, less than. That's it. Yeah, good job. That's what you want to recognize. So the next exam we take, which is after Thanksgiving, is that true? Yeah, after Thanksgiving. Anyway, the greater than, less than. That's the key mark on these. Greater than, less than. That's what's new, unique, special. Greater than, less than. So when you see greater than, less than, I've got a whole game plan. So let me just give you the method over here. For greater than, less than, greater than or equal to, less than or equal to, whatever. All those same kind of things. Step 1, change to equals and solve. Step 2, denominator alone equal to 0 and solve. Step 3, number line, true, false, true, false, true, false kind of thing. Oops, not another 3. Step 4, denominator equals 0, answers not included. Not included. All right, there we go. All right, so there's the steps that you want to go through when you're solving a greater than, less than problem. Greater than, less than problem with x in there. All right, so step number 1, change to equals. So here, it's already written. Let me just do it over here. So step 1, so I'm going to take this problem, which says greater than 0, and change it to equals. So there's step 1, change to equals. I'm going to change it to equals. All right, step 2, denominator alone equals 0. I don't have a denominator, so I can skip it for now. Some of the other ones in this section will have denominators. Skip it. We don't have a denominator. Step 3. Oh, wait, I didn't finish step 1. Change to equals and solve. I just changed to equals. I didn't solve. So, no. If two things are timesing to equal 0, that means either one could be 0, right? And then jump it over. So it's positive 1. And if it's just opposite sign when you have the parentheses equals 0. Right? Do you remember that logic? If two things times to equal 0, that's what this is saying. This times that equals 0. If I said, hey, I'm thinking of two numbers, they times to be 0. Either one could be 0 to make that happen, couldn't it? 0 times anything is 0. Or anything times 0 is 0. The front or the back one could be 0. So that's what you're saying. The first one could be 0 or the second one. Finish it up. X can be positive 1 or negative 5. Okay, so that's solving. So we changed it to equals and we solved it. Step 2, we skip. We don't have any denominator. Go to step 3. Go to the number line. Now, what do I mean the number line? So now you draw like a number line. And you put your two answers, positive 1 and negative 5. So here's positive 1. Here's, bless you. There's positive 1 and negative 5 on the number line. It breaks the number line, notice, into 3 sections. It's like if I took the ruler, which is now gone. I don't know where the ruler is. Up here? Wherever. Oh, yeah, there it is. So if I took this ruler and I cut it in 2 places, there'd be 3 pieces, huh? That's pretty much what I'm doing. I'm taking the number line and I'm cutting it in two places, and now I've got three sections. Got a left, a middle, and a right. You got three sections. Basically, the answer to this question is either going to be true, false, true, or false, true, false. It's going to switch back and forth. And we want the truth. So how do you know which of those is? I'll give more reasons for this stuff later. Let me just give you the method and get you comfortable with it first. So how do you know where? You have to check. So number line, true, false, true. I'm going to say you've got to find out which of those it is. How do you do that? You check for truth. So I'm going to check. So probably I should write right here. Check some point. I'm going to check 0 because 0 is an easy number. So I'm going to pick the easiest number I know, 0. And I'm going to use it to check if the equation is true or false at x equals 0. So at x equals 0, if I go back to the original, back to the x minus 1 times x plus 5 is greater than 0. If I go back there and I put in 0 there, and I put in 0 there, what do I get? 0 minus 1, 0 times 0 plus 5 is greater than 0. That's negative 1 times 5 greater than 0. You guys with me? So that's negative 5 greater than 0. Let me move it off to the side. There's a little more room. Are we good so far? I'm checking for truth or falsity at this spot in the middle, at x equals 0. I'm plugging x equals 0 into my original equation, my original inequality. And plugging in 0 for x, work it out, I get negative 1 times 5, which is negative 5, is greater than 0. Is that true or is that false? False. Negatives are bigger than 0? No, they're smaller than 0. That's false, which means this whole section is false. See, the 0 came out of the middle section. That means the whole middle section is a false section. The thing goes true, false, true, or false, true, false. Which one do you think it is? True, false, true. Now we know it must be true, false, true, because we've already found false in the middle. Does that make sense there? So, okay, so what's my answer? Well, your answer in math is always where the truth is. Where's the truth? Truth is right here in this section and right here in this section, isn't it? Those are the two zones, sections, in which the original statement will be found true. Any numbers less than negative 5 or bigger than positive 1? Less than negative 5 or bigger than positive 1? Answer A. And we're done. Does everybody see that? What we did there. Questions I can answer? No, so just running over it again. So step 1, you just change your greater than, less than, whatever you have, change it to equals and solve. You guys know how to solve this. You just set each one equal to 0 separately. Get your two answers, 1 and negative 5. Put them on the number line, 1 and negative 5. That breaks the number line into 3 sections. It's either going to be true, false, true, or false, true, false. It just switches back and forth. How do you know? Which one? Well, then you pick a checkpoint. You're kind of like an electrician checking for power. You're going to stick your multimeter right here, and it's going to go, yeah, there's power there, or nothing, dead. There's no power there, like checking a battery or something. You're going to check here to see if this wire in the middle is hot or not. Is there electricity there or not? I'm checking for truth, though. Instead of checking for electricity, I'm checking for truth. So x equals 0, that's a number between negative 5 and 1, right? 0 is. So I plug 0 into the original. Everywhere you've got x, I plug in 0, and I just work it out. Negative 1 times 5 is negative 5 bigger than 0. No, that's false. So it's false in the middle. My little device told me no, nothing's there.
It could be any number in between those two numbers.
It could be anything. Yeah, it doesn't have to be 0. You can plug in something over here. Yeah, you could plug in something over here if you want. Like if you had extra time on a test, you want to make sure you didn't mess up. You can plug a number in. What's something to the right of 1?
2.
Like 2 or 3 or 4 or 5 or 10 million. Plug that in, that should come out true. Plug it into the original, it'll tell you true. If you want to check more sections just to be doubly and triply sure. You could check other points than 0. You could check -1 or -2 or -3, anything in between the middle, and they should all come out false. And anything over here like -6 or -7 or -8 or -10 million, plug those in, they should come out true. Because that whole section's true. So you can do more checking to be extra sure. And there we go. All right, now I know some of that stuff, I didn't give you good logical reasons why. I just said do this, do this, do this, and it'll be true. So okay, so let's try that one. X plus 11 times x minus 13 less than or equal to 0. So go through those steps. So step 1, change to equals and solve, right? So first thing you do is make that equals. Make it equals. And so can we just skip some steps here? Minus 11, positive 13, right? Just opposite, opposite. We've done that enough times now. Minus 11, positive 13. So put those on the number line. Minus 11, positive 13. Right, those are my breaks in my stick, my ruler. So 3 sections. I always just go wherever 0 is, because 0 is so easy to use. But you don't have to. Any number will work. You can check the left, the middle, the right. It doesn't matter. Just check one of the sections. Find out true or false in one of the 3, and then you'll know which way it is, true, false, true, or false, true, false. So I'm going to go 0. 0 is right about here, isn't it? So I'm going to check x equals 0. And you take the original. And you put in 0, put in 0. 0 plus 11. 0 minus 13, 11 times minus 13, whatever, it's some negative number. Are negative numbers less than or equal to 0?
Yes.
Yes, they are. Negative numbers are less than 0, aren't they? You with me? This is true. Right? Negative numbers are less than 0, right? You all good with that? So that's a true statement. This is a true statement. So that means I'm the electrician checking for power. I'm checking for truth. I stuck my multimeter here and it went, yep, truth. Truth is there. That's a true statement. Negative numbers are less than 0. True statement in the middle. So which means it's false, true, false, isn't it? False, true, false. So the middle is the truth.
There's only going to be 2 answers. It's either going to be false, true, false, or...
Right, one of those 2, either true, false, true, or false, true, false. And so then the answer, the truth, is all the numbers between negative 11 and positive 13. How do you write that? How do you write all the numbers, all the truth is numbers between negative 11 and positive 13? You write x in the middle, and you write negative 11 and positive 13, because the x is the shading, remember. The x, the shading, is between negative 11 and positive 13. So put the x between negative 11 and positive 13. And which way do the greater than, less than symbols go? Both less than. That means middle. Do you remember that? I don't know if we've talked about that or not. Oh, yeah, we did with absolute value, back when we did absolute value.
Yeah.
We did talk about that. Yeah, remember, because that's what it means to be the middle. Like, think about like ordering a soda. Small is smaller than the medium, which is smaller than the large. That's what we're basically saying. The negative 11th is the smallest, which is smaller than, less than, the medium, and the medium is less than the large. This is in the middle. Right? The smaller is smaller than him, and he's smaller than the large. Right? Both less than actually conveys the truth, doesn't it? So there's our answer. What things can make that original statement true? All numbers between negative 11 and positive 13. All values between those two will make the original true. Is that good? How we doing? We happy about that?
Yeah.
All right. Okay, so let's try that one. So 15x times x plus 5 times x minus 5 less than 0. All right, you know what to do, right? Step 1, make it equal to 0 and solve. You have to set every part that has an x equal to 0. So the first step is change to equals. You don't even need to write it. You know what it's going to be, right? So every part that has a 0, every part that has an x has got to be equal to 0. So just change to equals, and then set every part that has an x. Now, everybody hearing me say that? If that 15 in the front was just 15 and did not have an x, I'll give you that in a minute, I would ignore it completely. Why? Because it can't make anything 0 if it doesn't have an x. If it's just 15, it's just 15. But if it's 15x, then it's got a variable. It could be 0. It can vary if it's got a variable, right?
0 divided by anything is 0.
So we good to there? So you set each part 0 and then divide by 15. X is just 0. This one, jump it over. Negative 5, positive 5. So now I go to my number line. I have 3 values, I've got 0. I've also got negative 5. I've also got positive 5 on my number line. We good to there? So what does that mean this time? It's going to switch back and forth. It's going to be true, false, or false, true, false, true. It's just going to switch back and forth. It always, well, for now, it always switch. For the problems that they'll give you, will always switch back and forth. You go higher pre-calculus, they don't do that. And we got to talk about more complexity. But for these, they'll make them always switch back and forth. It'll always go true, false, or false, true. It'll switch. So we just need to find one of them, It doesn't really matter which one. Since we know the pattern is just a switching pattern, we only need to find one of them, and then we can get all the rest from the switching action. Right? Isn't that good? So which one should we find? Doesn't matter. Find any one you feel like. But you can't use 0 this time.
Oh.
Why? Because 0's right on the line. 0's on the border. 0's the cut. It's one of the 3 cuts. You got to use a point that's in between the cuts. So we can't use 0 this time. 0 is one of the cuts. So what are we going to use? What's the next easiest number you know after 0? 1, yeah. I would probably just use positive 1, which is right there in the 3rd section. But you could use like 6 or 7 or something in the right section if you prefer. It doesn't really matter. Just check one section. So I'm going to do positive 1. I'm going to check x equals positive 1. And how do I do that? How do I check x equals positive 1? Plug it into the original, right? So I'll come up here and go, okay. So I'm going to plug in 1 for x everywhere, right? See if it's less than 0. So what's that? 15 times 1 is 15. This is times 6. This is times negative 4. I don't even bother to work out the numbers. Look, positive times negative. It's negative. I don't care what the number is. It's negative. Is negative less than 0?
Yes.
Yeah, sure. That's true. That means that's a true section. I checked for power, checked for truth, and the little meter said, yep, that's a true section. So then they just switch back and forth, right? So this must be false, this must be false, and then back to true.
True, false, true, false.
Must be, huh? We good? Everybody seeing that? And so the true sections are here and here. There and there. Now how do you... This time we have two chunks, don't we? Two chunks that are shaded. How do we actually say... Am I racing ahead of you? You good to there? This making sense? We good to there? Okay, now how do you say this left chunk over here? Remember, the X is the shading. If you were to tell your friend on the phone, you were working math on, you ever talk to your friend on the phone about math? And you were to say that this is shaded, what would you say? You would say it's shaded left of -5, huh? So in other words, X is less than -5, isn't it?
Okay.
Isn't that what that means? Left of, left is less. Aren't lesser stuff, aren't the lower negative numbers to the left and the bigger positive numbers to the right? So being to the left always means you're less, huh? Being to the right always means you're greater. Okay, now, how would you tell your friend about this shading? This other shading trick. You wouldn't just say, oh, left of 5. Well, no, that would be like all that. You would say it's between 0 and 5, wouldn't you? Right? Isn't this chunk of shading between 0 and 5?
Greater than 0 and
So, you know what we do when we have a chunk between two numbers? Remember, the shading is the X is the shading. They are 1. You'd say the X is between 0 and the 5. The shading is between the 0 and the 5. And when we do the between thing, how do the symbols always go?
Greater than or equal to?
Both less than. Right? What we did just a minute ago, right? You guys with me? Like on this one? Right? Both less? But whenever you do the between, it's both less. Everybody see that? Whenever you do the between, it's both less. Because small is smaller than medium, medium is smaller than large. That's what it means to be in the middle. You're the medium. So the smaller is smaller than you, and you're smaller than the large.
Oh, 0 is less than X, but X is less than 5.
Right. Right? Isn't that true? X says, I'm right here. I'm the shading in the middle. 0 is left of me. 0 is the left edge of the shading. And I am left of the 5. I am left of the 5. Right? No, not right? There we go. There's our answer. I think they want you to stick a comma between those two. I think that's what they want. Maybe we better go back and type that in and see if that's what they want. Let's go see. Yeah, so here, so this is the answer. Or if you want, you can replace that comma in the middle with the word or. Either way. Questions I can answer on that one? Is that okay? So we take each part that has an X equal to 0, solve them all, put them on the number line, just test one section. If I found it's true, and then it just switches back and forth. Give the true answers. All right. All right, so now we're going to fraction time. 1 over x minus 9 less than 0. So now we're talking fractions. Okay. So it's the same. Remember the 4 steps I wrote out? We've been skipping step 2. And really we haven't been doing anything on step 4.
Get
Yeah.
the denominator alone.
All right, so remember step 1. Step 1 is, what is it? Change to equals. Change to equals and solve. Okay, so we'll do that. Let's change to equals and solve this thing. So 1 over x minus 9 equals, so change to equals. And then how do I solve that thing? What do I do to solve that thing?
Get done with common denominator.
Hey guys, if I said, hey, I've got a fraction. I've got a fraction and it equals 0. How can a fraction equal 0?
Anything divided by the bottom. 0 divided by anything, 0.
So how can a fraction equal 0? How do you make a fraction? What if I said I'm thinking of two numbers, I'm dividing them and it's coming out 0, what do you know for sure?
You have to cancel out the bottom one.
How can a fraction equal 0? Can you make the bottom 0? Will that make the fraction 0?
No, you cannot divide.
What happens when you make the bottom 0?
There's no solution.
0 underneath is undefined. Remember, it's an error on your calculator. So that won't make the fraction 0. How do you make the fraction 0? You make the top 0. That's all it means. Huh? The only way to make a fraction 0 is to make the top 0. 0 over anything, like 0 over 7 or any number you want, is 0. Right? If I say I ate 0/7 of the pie last night, it's a weird way to say you ate no pie. Right? Right? 0 in the top of a fraction means 0, doesn't it? So when they tell us some fraction is equaling 0, you know what you should think? You should think the only way that's going to happen is if that numerator, that top, is 0. But the top's not 0. It's 1. Right. So there's no answers to that. Do you see that? That top can't be 0. It's 1. And it doesn't have an x. It can't vary. It's 1, period. So it's not 0, period. So there are no solutions to that. There's no way in the world that fraction is ever going to equal 0. The only way to make a fraction 0 is to make the top 0. And that top can't be 0. Right? That hitting you? That kind of thought never hit you before? Right? Fraction equals 0, the top's got to be 0. So, now that's just logic and looking and thinking. I'll give you steps, but logic is always better. But I mean, if you know logic, you'll be well. You'll get the right answers because it'll catch small mistakes. But I'll show you the formalities. What would the formalities be? The formalities, if you want an actual method, is just put that over 1, remember, and then just cross multiply. You could do that. You're going to get no answer. But I'll show you the formalities. It'll be 1 times 1 is 0 times x minus 9. Remember, we've solved fraction things before, huh? We just put it over 1 and cross multiply. Right? And then what's 1 times 1?
1.
1. And what's 0 times anything?
0.
1 equals 0. Where'd the x go? See, there's no solution. No solution. That's the more formal way. Or you could just look at the thing and go, not going to happen. Right? Top can't be 0. All right, so that's all step 1. Change to equal solve. We got nothing. We got nothing out of step 1. Step 2. Now, do you remember? I've been skipping step 2. Step 2 is denominator alone equals 0. Denominator alone. Just the denominator, having no reference to the numerator whatsoever. So all this is step 1. So now step 2, denominator alone. What's the denominator? X minus 9. Alone. Just that. We don't care about the numerator. We don't care about anything else in the problem. Just denominator alone equals 0. X minus 9. So solve that. Move it over. X is 9. There we go. So we got that answer. That's the only answer we have so far because we didn't get any answers out of part 1, huh? Out of step 1. So that's that one. And now step 3. Now it's number line time. So when I go to the number line, what's going to go on my number line? I've only gotten one answer, huh? 9. So 9's on my number line, and that's it. So this time I'm taking the stick, I'm taking the ruler, and I'm only cutting it in one place. So how many pieces do I have? Just 2. We just got a left and a right. We don't have a middle this time. We just have a left side. It's going to be true, false, or false, true. Isn't it? We need to check. So how do we check? No, we don't want to check the cut line. You want to check one or the other of the section, in the middle of the section. And my favorite number, the easiest number, is 0, right? So where's 0? Somewhere over here on the left. I always use 0 when I can. As long as 0 is not a cut line, I always use 0. So I'm going to check x equals 0. How do I check? Where do I check?
0 equals 9. X minus
Back in the first step. It's always the first step, huh? Whenever we check anything in math, it's always the first step. So what do we get? 1 over 0 minus 9 is less than 0. I just put in 0 there for x. That's good. 1 over minus 9 is less than 0.
Yes.
1 over negative 9 is less than 0. Is this right here a true statement or a false statement?
It's true.
Don't let the fact that it's a fraction throw you off. Who cares? It's a negative number. All we care about is positive or negative. It's saying negative, this negative thing, fraction, whatever, who cares? This negative thing is less than 0. Are negative things less than 0?
Yes.
Absolutely. That's true. So that section, we checked with our multimeter, put it in here, and the instrument said, yep, true section. So that other one must be false section. So the answer must be all the things in that section. How do we say all the things in that section? X is less than 9, right? Isn't the shading all the numbers less than 9? All the numbers less than 9. That's the final answer.
Wait,
Yeah.
stop at the, oh no, it stop at the 9.
Yeah, the arrow keeps going, right? Yeah, it stops here at the 9. Does that make sense? We just had 2 sections, right? The 9 was splitting the whole number line into left of 9, right of 9. And I checked the left section and it said, yes, true. So all the numbers left of 9, anything less than 9, is an answer. Is that good? How we doing?
So because we only have the true false, we only get one answer, right?
Yeah, that's right. Just one section, huh? Just one chunk, yeah. Whereas this last one, we had a couple of chunks. We had this and this. So we had less than negative 5, and then we had between 0 and 5. Yeah. Yeah, basically, you're going to have one X for every shaded chunk. Maybe I should say that. Maybe that'll help. If you got 2 shaded chunks, you got 2 X's in your final answer. Is that making sense? And whenever the shading goes off the edge, hits the arrow, left or right, either edge, that's when you just have one statement, one number. But when the X is between 2 numbers, then you have the X between 2 numbers. When the shading chunk's in the middle.
Oh, there's
Right.
3 sections.
No, I'm just saying when the shading chunk is in the middle of 2 numbers, you write the X in the middle of 2 numbers. But when the shading chunk goes to the edge, you just have, less than negative 5 on that. Is that good? So this one goes to the edge, less than 9. Question?
We did not do step 4, just up to step 3.
Yeah, we don't need to on this one. I'm holding off. I'll bring it in. Yeah, not needed right now. Okay, let's try that one. X plus 19 over X minus 10 greater than 0. All right, so try to go through those steps. So remember step 1. Step 1 is change to equals and solve. So that means just make that equals, right? And solve that. And so how do you solve when you've got a fraction on one side and a whole number on the other? Put that over 1 and cross multiply. All right? Is that good so far? Just like that? Take it from there. Keep working. And distribute. And 0 times anything 0, huh? We good there? And then move that 19 over.
X equals -19.
Negative 19. We good to there? So we got our X answer there. We good on that one? So that's the answer from step number 1. Now we can go on to step 2. And what do we do on step 2?
The denominator alone.
Denominator only or alone, yeah, equals 0 and solve. So grab now just the denominator, nothing else, equal to 0. So that means x is positive 10 when you jump it to the other side, huh? So we've got negative 19 and positive 10, and then we go to the number line with those two numbers. Is that making sense so far? Am I going too quick? Is that making sense? So step 1, we change to equals and solve. Step 2, just the denominator and solve. Equal to 0. Just denominator equal to 0 and solve. Like that. And then go to the number line from there. See if you can go to I'll let you finish that up rather than me just whoop them out all the time. You get more out of it. So put those on the number line. See if you can find the true, false, true, or false, true, false thing. So we go to the number line, and we put minus 19 and positive 10 on the number line. Isn't that good? And then we need to check. We have left, middle, right. So you can check wherever you want. I always go wherever 0 is. 0 is in the middle, isn't it? So 0 is right here. I'm going to check. X is 0 right there. So where do we always check?
The original.
The original. So always the first step, huh? So grab that first step right here. Grab that first step. Bring it on down. And say, okay, x plus 19 over x minus 10 greater than 0. And put in, and in the place of x, you're putting in 0, huh? So 0 plus 19 over 0 minus 10. What's that going to be? That's going to be 19 over minus 10 is greater than 0. Is that true or is that false? Don't even need to work out what that is. It's a negative number, huh? That's something negative, right? Positive over negative is negative. Bless you. Negative number is bigger than 0. Is that true? Is a negative number bigger than 0?
No.
No, that's false. So that means that middle section is false, and the other two must be true, huh? Does that make sense? So this is true, and this is true. Those are the two true sections.
So anything greater than 10.
So how are we doing? Is this making sense? Not sure I'm communicating with you guys today. You guys look a little phased out. Is this making sense? These steps good? Anything I can say to help? The direction. So we good to here then with all those steps to here? So see how it's kind of the same every time. Step 1, change to equals and solve. Step 2, denominator only and solve. Then go to the number line. And now then you check wherever 0 is. That came out false, so the middle's false, so true, false, true. Yeah, now how do we say the answer? So the answer is here. And so the x is the shading. What is true of the shading? Well, it's left of negative 19, huh? How do you say left of negative 19?
Less than negative.
Less. Left always means less. Right means greater, huh? You with me? So, and how do you say right of 10? Greater than 10. Put a comma in between those two. Right? To the right of 10 is greater than 10. To the left of minus 19 is less than minus 19. And that's it. We don't have any shading here that's between two numbers, do we? We don't like looking at the last one. See how well that one either. Here we go. See how we had shading right here that was between two numbers? That's when you put an X between two numbers with both less than statements. That's for a between section. Everybody seen how to do that? When you have shading between two numbers, you put the X between two numbers, both symbols less than. But if you just have shading left edge or right edge, left is less, right is greater, right? So left is less, right is greater. So the final answer then, maybe I could write it, well, there's just not any room left. It's right here with the comma in between. X less than minus 19, comma, X greater than 10.
I think we need to do a few more of these.
Is that good? Is that making sense? Questions I can answer? That good? All right. Sense. Because now they're ramping it up a little bit. This is where it gets a little bit ugly. So, okay. Let's write out what we're doing. Step one. What is step one? One down. That's 3 over 1. Diagonal kind of thing, right? Like that. That good? Solve for X there. Okay, so we got 1, X minus 9, 3, X minus 10. Solve that thing. Boom and a boom. Right? So we get X minus 9, boom, boom. 3X minus 30. Like that. How do you solve for X when you got X on opposite sides like that? What do we do? Yeah, get rid of one of them, huh? Subtract one of them, like subtract X from both sides or whatever. So then we got minus 9 is what? 2X minus 30. That good? Right, when you got X's on opposite sides, you got to get rid of one of them, right? It doesn't really matter which one. Get rid of one of them. Add the 30. And what do we got? There's that 21 is 2X. Then last step. Divide by 2. I would just make that, was that 10.5?
Yes.
Oh,
10.5? Yeah, I would just go to a nice decimal. 10.5? So that's our answer from step 1. That good? So there's our answer from step 1, 10.5. So now go on to step 2.
Denominator alone.
Denominator alone. Denominator alone equals 0. So denominator alone. So what's the denominator alone? That's just the x minus 10, huh? So x minus 10 equals 0. Move it over. X is positive regular 10. Good there? So we got our two answers now. We got our 10.5 and our 10. Those are close. 10 and 10.5 are our two answers. Go to the number line now. So now go to the number line. And I would check where 0 is. And 0 is going to be on the left this time. It's in the left section. As far as the left, middle, right, 0 is in the left on this one. So make your number line. You'll see what I'm talking about.
Mr. Graham, would you be able to do like a 10.2, for instance? Or,
You could, but I wouldn't do that. That's okay, but why make it hard like that?
it just gives me 6 when I plug it back in.
We're looking for true or false.
It's true. It looks true. I could be.
Yeah, I think you're right. I think it's true. Yeah. Good there. So we got our two answers. I'm going to change to a fresh screen here. So So what was our two answers? 10 and 10.5, right? Those are the two answers. Go to the number line. So 10, I'm going to put 10 here and 10.5 there. Even though really they're close together, I don't care. I'm just going to space them out to help me be able to do my work. Where is 0? Way over here in the left edge, isn't it? 0's way over here. I always go wherever 0 is. I'm going to check x equals 0. Is it warm in here?
No. Yeah.
It's good stuff here.
So when we all start getting drowsy, huh? When they turn the temperature up a little bit. I've noticed that. I mean, it's just 'cause I'm old now. I sit in my office, I'll start like nodding when I'm doing work in the afternoon, and I'm like, what? I go over to my thing on the wall. I can control the temperature of my office. I go, I need some air. Then I'm much better. Anyway. All right. So x equals 0. Let's plug it in. So we're going to check. What do we check? The original. Always the original whenever we check anything in math. Huh? Check that original. X minus 9 over x minus 10 greater than 3. Plug in the 0. Plug in 0. Minus 9 over minus 10 greater than 3. That's positive 9/10. Divide that in your calculator. 0.9 is greater than 3. No, it's not. That's false. True, false. Good? Let me see what I did there.
So anything less than 10 is false.
Everybody good there? And so the answer is just the true section in the middle. That's the only true section. How do you say, what do you do when the shading is between two numbers? You put the x between the two numbers, huh? Because remember, the shading is the x. What you're saying about the x, you're saying about the shading. You're saying about the truth. So the shading is between two numbers, the x is between numbers, and which way do the symbols go? Which way do they go? Haven't we done this enough times to where with one accord we can all say it clearly?
In the middle. The X goes in the middle.
So which way do the symbols go? Right, the x goes in the middle. So which way do the symbols go? Whenever you put an x in the middle, there's only one way they both go. They both are less than, huh? Is that making sense? On that, they're both, because that's the small, medium, large thing. That's what it means to be in the middle. The small is smaller than the medium is smaller than the large. So it means to be in the middle. Are we getting the hang of that? That okay?
10 is less than x, which is less than 10.1.
Yeah. Yeah, 10 is left of x, and x is left of 10.5.
Because it's not greater than 3.
Is that good? There's orange. In other words, the only numbers that make this original inequality true are numbers between 10 and 10.5. That's not many numbers, is it? Actually, there's an infinite number of numbers between 10 and 10.5. Aren't there? What's that?
Technically, technically speaking.
Yes. But you know what we mean. It doesn't seem like a lot of numbers. Not a lot of range. How about that? All right, we good? You guys doing okay? I don't know whether to speed up or slow down today, guys. I can't read you. I'm getting
Slow
nothing.
down.
You guys are giving me the poker face again. Let's try this one. Okay. So let's try that one. Let me give you a minute on that one. Should be pretty standard. Nothing too weird here. So try that one. So we got x equals 0. We got x equals 8. Everybody good with that? So step 1 was over here. I just changed to equals, and then I put this over 1 and cross multiplied. We got x equals 0 as my answer, because 0 times anything is 0. And then over here, denominator only, just this denominator equal to 0, and that means positive 8. So now I've got my two numbers. Go to the number line. It's kind of getting the same every time. Getting the hang of this? So go to the number line. 0 and 8. Now, can we check 0 this time? No, he's a cut line this time. So we got to check something other than 0. Like, how about 1?
1.
Yeah. 1 would be fine. So x equals 1. Check x equals 1. And where do we always check anything we check in math? The original x over x minus 8 greater than or equal to 0. Put in the 1. I'll bring it over here. 1 over 1 minus 8 greater than or equal to 0. 1 over minus 7 greater than or equal to 0. Now, 1 over minus 7, that's a negative number, right? Positive divided by negative is negative. Are negative numbers bigger than 0? No. That's false. So it's true, false, true. Shade the truth. We're always looking for the truth. So, all right, so how do we say those two true sections? Right, we're going to have two X's in our statement, aren't we? Because we have two shaded chunks, don't we? We have one X for each shaded chunk. So X is less than 0, right? Isn't this section here less than 0, left of 0? So it's X less than 0, comma, and this is right of 8, X greater than 8. Oh, wait a minute. The original had greater than or equal to, didn't it?
Yeah.
So I got to make these great. You got to keep the equals, right?
Less than or equal to and greater than or equal to?
Yeah, got to keep the equals. Right, we good?
So all the true is what's shaded, right?
Yes.
Okay,
I shaded the truth.
okay.
Yeah. Everybody good with that? Because I have one more small wrinkle on this one.
Are you kidding me? I thought I finally got that.
It's almost the answer. It's almost. It's very, very. I got to erase one small line, and it's good. But everybody good to there? Does that make sense? Right? The shading is everything left of 0, so that means less than 0. Left is less. And everything right of 8, right is greater. Good? Now here's the one small exception. Can't ever make a denominator 0, right? Remember, that's the big no-no in the math world. Your calculator gives you error. Take 7 divided by 0, goes error.
Right.
So any number that makes the bottom 0, that's not allowed. That can't really be truth. It's wackiness.
Oh, so it's only greater than 8?
Yeah. If you put an 8 in here, that's going to make that bottom 0. The number 8 cannot make the original statement true, can it? There's no way. If you put 8 in for X, the top's fine, but look at the bottom. The bottom's 0. You cannot. Anything that makes the bottom 0 is for sure not included in the answer. In other words, whatever comes out of step 2.
It can only be greater than it can be equal to.
Right, because out of step 2, we got the 8. Do you see that? Out of step 2, that's denominator 0 step. So anything making the denominator 0, anything coming out of step 2, you can't equal that thing. So you can't be equal to 8, you're only greater than 8. You can be like 8.1, but you can't be 8 right on the money. So that's the one extra little wrinkle you got to watch out for. You only have to worry about that, guys. The reason I haven't even said anything up to now is because all the rest of the problems started with just greater or less. They didn't even have an equals in them. This is the first one that actually had greater than or equal. And so if they don't even have equals, well then who cares? Don't even think about it. We're not trying to equal anything. We're just greater or just less. Don't even worry about it. But if they say greater or equal, then yeah, you got to make sure you don't actually equal an answer that would make the denominator 0. The equals, questions on that? Am I good? We good and happy with that? All right. In that section.